my webinar. I also thank you for allowing me to speak in English. I'm spending more time these days in Mexico, and I really should learn Spanish, but whatever Spanish I have is not adequate for the for presenting a webinar yet. It's something maybe I can aspire to. So this is choosing analytics is a large subject, has lots of ramifications and lots of controversies, and I can only cover a little bit of that in the time we have. So I'm going to add more of this topic and more of the principles that I'm mentioning today will be presented at the upcoming Software Guru Cutter Agile conference at the end of September. So this is a little bit of an introduction to that. So let's get started. Hold on, there we go. So as Jorge mentioned, over the years, I've heard lots of things from lots of developers, and one of the questions you ask and you sort of need for doing analytics is, so we have a new program, how long do you think it'll take? And developers' usual answer is, well, they have no idea. And on the other hand, the business needs to know in order to make its plans, and the developers don't have a good answer. So what tends to happen is they will give you an answer knowing it's not right. You will take the answer as the answer and take it to start planning in the business. And in the end, everybody has a bad time because nobody has recognized the fact that both of these are uncertain answers. Both of these are uncertain quantities. There's risk involved in all this, particularly for interesting work. And the question that we're going to talk about today in a fair amount of detail is how to overcome this typical adversarial relationship that builds between developers and management. Other methodologists will tell you that measures are a waste and they're costly, that in the end, measures interfere with the real work, and they tend to oppress workers. And there's some legitimacy to these concerns, and the way to deal with this is to choose the right measures that communicate the right information and are actionable and helpful to both the developers and to the management. We'll talk a little bit about that. And then sometimes methodologists will say, this is particularly over the years, I've seen lots of methodologies come and go. Currently, Agile is the most common methodology. And some of these are very well founded. Some of these have been built on good principles. But the true believers of these methodologies just tell you to trust their process. And if the process isn't working for you, you're doing it wrong. Our answer to that is a lot of these processes are good, but unless they're instrumented and measured, you don't know where the problem is, and just blaming the practitioners is certainly not the answer. So with these sort of thoughts in mind, I'd like to go forward. As I've said before, each of these comments have generated lots of heated disagreements over the years, and part of my vision and goal and hope is that we can get past these kinds of arguments and ground the choice of analytics in a way that is with good principles and gets us past these sorts of arguments. So the first concept is, oh, and by the way, I've got to apologize. Something happened in the formatting of this presentation, and some of the charts are sort of messed up. And we'll provide a cleaner version of these charts after something happened in the transformation to PDF or something. But the first choice is measurements are essential. The reason you do measurements is you want to know if you're on track for achieving some goal, and they should always be part of some sense and respond loop. So when you're choosing a measure, you should ask the question, do I know what I'm doing? Why I'm choosing this measure? What is it? What is its function? What goals do I try to achieve? And are these goals giving me are these measurements giving me some way to respond. So for example, I have a doctor who wants me always to check my blood pressure. My blood pressure has been fine for years, but he always wants me to check my blood pressure. And the question is, if I had a bad blood pressure reading, I don't know what I would do with it. I mean, so maybe I'd call the doctor, but probably I wouldn't. But unless I had, the point of just taking the measurement for the sake of taking the measurement is a waste of everyone's time. If on the other hand, if you know what you would do with the measurement, you have a way of responding in some way, then it becomes useful. So if you have a goal of, say, lowering your blood pressure and you have a way of adjusting your medication based on the measurement, then you should take the measurement and you should respond accordingly. And that's how all measurements should be. They should be part of a sense and respond loop. Know what goals you're trying to achieve, know what measurements mean in terms of whether you're achieving those goals, and know what actions you would take in response to the measurements. So when you're picking measurements, then there are really two sets of considerations for development. There's the measurements that depend on the mixture of the work that you're doing, and we're going to talk about this in most detail in this presentation. That for different kinds of work have different kinds of goals, which require different kinds of measures, and also the level of organization that you're at. And we're going to talk about each of these separately. So let's talk about the level of the organization first. What happens in businesses is that essentially there are levels of concerns that flow up and down the organization. So the line of business executive, his goal or her goal is to the enterprise is things like profit, return on investment, and if it's a not-for-profit kind of business, some sort of mission fulfillment. Maybe they're trying to save acreage for conserved land, and they're not trying to make a profit, but the amount of acreage they save for dollars spent would be a good measure for a conservation organization. But in any case, the person who's in charge of the line of business has very clear business goals. Now, a senior manager who's, say, in charge of development or IT or systems, they have a role to play in helping the organization meet its goals. But the way they fulfill their role is involved in delivering some set of services that have value and are in an efficient manner. So they may be the new products or ongoing operations of the IT system, minimal downtime. These are the kind of new features for new products for the bank. These are the things that they commit to because these provide value that helps the line of business make its goals. And then the project team and the team lead is assigned a project, actually maybe where the senior management have gone through the portfolio management process, and their goal is to deliver specific projects on time and in a way that is affordable and on budget. Now, this gets in the face of some of the agile methodologies who say you can't commit to on time and on budget, and this has been a source of great friction in the development community. And we'll talk about the fact that the business does need the projects in a timely fashion in order to do its work, and at the same time committing to firm estimates when you don't have the information is also a non-starter. And then the staff members who work in this, they have to work on artifacts, they have to get test cases done or work items done in certain methodologies, and their commitment is to at least get the work that's been assigned to them done for the current sprints or whatever. Now these, if you think about it, each one should support the next one. So the goal, so the goals of one level of management impact. I'm sorry. The goals of one level of management help determine what the goals of the next level of management down is, and then to the next level and down to the next level. So the goals flow down the organization. In order for the business to deliver its goals, the senior management of the development organization has to provide a set of results to the business. For that to happen, the project leaders have to meet their goal, have to deliver on some sets of projects, or the team leads have to deliver on some sets of projects. In order for that to happen, the individual workers have to do what they've been assigned to do, or what they take ownership of. And so what that means is that the analytics sort of flow up the organization. So what we would have to measure at one level of the organization, at the bottom is, say, the completion rate of the work items and the time that they take. That helps understand whether or not the project is on track to provide value to the line of business, and then the line of business has to be able to talk to their management on the what they will actually accomplish in order to support the business. So while the goals flow down, the analytics flow up. And one of the key functions then of analytics is to align the business with to align the levels of the business. This is a key thought for lean management and agile management and the like. That is, and in particular, every time you create analytics at each level, you should ask the question, does this support an intelligent conversation between the levels? So when the project manager is talking to the worker, when the worker meets their goals, is it helps supporting the project manager's goals? And when she has that, and then she can have that conversation, and then when she's taking her analytics, will that have the right conversation moving, supporting the functional management who supports the others? And again, what these particular measures are will depend on the mixture of work, which we're going to talk about the next time. But when you choose goals at each level, you should always be asking the question, one, are these in support of a control loop or a sense and respond loop? And secondly, are these aligned top to bottom? Now let's get into some much more detail. But that has to do with the mixture of work. Now, for development, one of the reasons that analytics are hard for development organizations, and this helps choose the goal, and these considerations will help choose the goals at each level of management. But one of the reasons the development is analytics is hard for development organizations is that development organizations, in its essence, do really three kinds of work. Much of what they do is what I call bug fixes, small changes. This is when there's some system that's out in operations, it's in the marketplace, it's being executed by the IT organization, and problem reports come in, bugs and point releases need to go out to address the problem reports, or sometimes they're not even problem reports, but they're change requests. We would like you to add one more field to the database. We would like this interface to actually be moved, this interaction to be moved one screen above in the interactions, things like that. And these tend to be things where there's very little innovation involved. We understand with high certainty what the requirements are and what code needs to be done. So there's not a lot of innovation here. This is bread and butter day-to-day work. And it doesn't often even involve a project. Often what happens here is there's some sort of maintenance or level 3 support team, and they get problems, change requests get brought to them, they work on them, and they put out periodic what are called point releases. This is what we call bucket 1, and this is the low innovation, small changes. Now, roughly in our experience, we've asked this question lots of times of development organizations. Roughly 60% of the effort in most, and sometimes as high as 80% of the effort in organizations is devoted to this bug fixes, small changes piece of work. And some organizations like outsourcers and the integration team, say in India or Vietnam, this is all they do. This is often work that's, as I said, put offshore. Now, so that's bucket one. Bucket two is when they have a existing application and they want to go from version 1 to version 2, say. And in version 2, it's going to have some neat new features that the customers have been asking for. In this case, there is an existing architecture, but there's some discovery, but there's some uncertainty as well. So in the first case, you're very able to predict with quite high certainty, with probability, how long something will take, how much work will be done. The question is, how long will it take to do this is a reasonable question. In problem two, in the sections two, now, much of the work, you have an architecture, you may or may not need to refactor it. You have pretty good requirements because they're based on the existing application. So there's some uncertainty on whether this new feature will work in the new technology, and there's some perhaps lack of clarity in the application. But in either case, so you have some uncertainty in how long things will take. But that uncertainty can be worked off sort of quickly. But so in bucket two, we say we have some innovation, there's some new invention required, and there's some uncertainty associated with that. And then every so often, there's high innovation, should be low certainty, not low uncertainty. And I'll fix that. And what happens here is this is a whole new platform. We might not even have an architecture. We haven't chosen technologies. What we have is a vague description of some functions that need to be built. And so when you ask the developers how long will it take to do this kind of work, the answer that we don't know is very legitimate because they don't know. They don't have complete information about what's needed. They don't have complete information about how the technology will work, and they don't have complete information about what the users really want. And they don't have complete information about how well the team can do at building this kind of application to begin with. There's just a whole lot of discovery that has to happen. So now the key point here is analytics that work here and analytics that work here and analytics that work in the third thing. Bucket one analytics, bucket two analytics, and bucket three analytics are quite different. In bucket one, you can really think about product flow through and think of it more like sometimes people think about product flow and lean technologies, lean methods, and almost factory techniques. Not quite, but in three, it's much more about design and the removal of uncertainty is what is actually the key measure of progress. So setting sense and respond loops here and sending sense and respond loops here are just different. That's a conversation that needs to be had. What's also interesting, we're going to talk about this in much more detail at the upcoming summit, is that methodologies that we've all been talking about over the years of Agile, Lean, the Agile Scrum methods, said the Lean methods, systems engineering, Lean startup techniques, DevOps and continuous delivery, Kanban. These all work well somewhere in this landscape, but no one technique works in everything. And because of this, it's not surprising, again, that there are different analytics for different parts of these methods, for different parts of this, what I call the risk curve, or the analytic, or the work mix. So what we're going to do is talk about two sets of analytics today. We're going to talk about the kind of analytics, whoops, what was that? We're going to talk about the kind of analytics that work in bucket 1 and work into bucket 2, and we're going to talk kind of analytics that work for bucket 3 and then also on the way into bucket 2. What's interesting about bucket 2 is that it's a mixture of sets of techniques, and that's what makes particularly challenging. One of the common mistakes that organizations make is to get good at, say, bucket 1, and they think that's going to work for new innovative projects or new features, and they end up with the wrong set of measures and the wrong set of sense and respond loops, and these leads to the kind of arguments I talked about earlier. So this little thing should be marked, this should be moved on the chart. But so we're going to talk about the low innovation efforts first. Now, as I said, the uncertainty is low, but there are challenges in measuring these kinds of flows. The principles, the challenges that come from managing a bucket 1 organization, a bucket 1 team, are twofold. One is that the work doesn't come in as a steady rate. They tend to come in clumps. Some days there'll be no change requests, some days there may be 5. Next day there may be 7, next day there won't be any. So you always have to have some amount of, you keep a backlog of the things that you can work on, and you take things off the backlog, and this is the essence of the Kanban techniques. The second thing that makes this challenging is, unlike a factory and the Six Sigma techniques, every change request is different. In a factory, every product item is the same. If you're making light bulbs, every light bulb is supposed to be the same, and the purpose of Six Sigma measurements is to check the is to keep the variations between the light bulbs very minimal. In software, every change request is different. Some are very small, some are rather large. And so managing the flow and measuring the flow of work products when you have unsteady delivery and different artifacts at each stage requires a different look at the metrics than you get before. So we have random arrival intervals, and we have variations of effort to address the work items. So one way to do that is to look at take a look at the work items themselves and take a value stream approach to looking at them. And this is a way to do that. If you're interested, if you understand value stream maps, this is an example. But what happens, what you think about is you take each work item that comes in and you think to yourself, well, it's in one of two states. It's either in process, it's either in a wait state waiting to be worked on, or it's in process where it's taken from one state to the next state. So for example, a change request can come in, and the first step is to do a triage or prioritization, where you decide if this is an important change request or one you can ignore. So the state transition, so the feature goes from unprioritized to prioritized. Then once it's prioritized, it ends up in the backlog of the development team, who takes it and says, takes it from its backlog and goes from unimplemented to implemented. So now the feature is now not only prioritized but implemented. It's gone through yet another state transition, and then goes to another state transition where it's released, and another state transition where it's deployed. Where it's evaluated by the customer. So in each case, it goes between a wait state and an in-process state where it goes through transitions. Now what you can do is you can measure the amount of time things spend in the wait state. You can measure the amount of time things take in the transition state. You can measure the size of the backlogs in each of these states. And you can look at the end-to-end time, and you can set goals around them. For example, one of the goals is that the total lead or end-to-end time is less than is is diminished by, say, 10 or 20%. This makes your organization more responsive to the customer. And you may be able to do that by adding more automation or more workers at each of these state transition points. So you have a clear measure, which is I want to reduce the end-to-end time. I'm going to do that by measuring the amount of time it spends in each of these states so I know something about them. And then if it takes too long in each of these states, I have some action I can take, either assigning people, putting in better automation, or asking the team itself what maybe there's too many approval steps and maybe I can remove some of that. This is really the essence of lean thinking. So what would those measures look like? Well, what I'm going to do, as I said, I'm going to measure the, the I'm going to measure the amount of time things spend in the wait state and the amount of time things spend in the transition states. And again, I apologize for what happened to these charts. And here's what it looks like. What you get is, because each of these work items is different, you can't really look, the kind of statistics you need to look at to get the right insights are what we call histograms. And what histograms is, for example, if I look at the end-to-end time, a histogram is I'm going to count the number of, on the x-axis I have the number of days it takes to ship. And on the y-axis, I'm going to have the number of items that took that number of days. So what happened is for just 10 days or whatever this is at the bottom, there was only 2. I have a peak somewhere around 40 days in this case, and then there's a very long tail. And this is a typical distribution or histogram for the time it takes to get through one of these teams. I've looked at many, many, many organizations, and I've always seen curves that look like this. Now, and so in this case, I have what the backlog time in backlog look like, what the time in process looks like as histograms, and the overall time end to end. So this is something now. Gives me a picture of what's going on. That most of the things get done in. Some of the things get done in a few days. Most of the things get done in not too many days. In fact, I can find the 50% point on this cumulative chart as being somewhere around here. And then I have a very long tail for some things that take forever. So I can do several things with this. I can ask the team, what's going on with the tail of this distribution? Why is it that some work items just take forever to work on? And often what they'll tell you is, well, it turns out those were prioritized wrong, or it turns out there was no way to fix them, or they've just been left in the database. We never planned to work on those. And so those can be, so it turns out that those aren't a very good, so accounting for those, and if you take averages, you'll end up accounting for those, turns out not to be very useful. So a good measure is to sort of, is to take, say, the 80% point, which is somewhere around here, and what you'd like to do is reduce that 80% point going inward. That would be your goal. You ignore the tail, but you want to squeeze up the time it takes for 80% of these defects to be done, because this would be a reasonable goal. You have a way of achieving it. It means you're more responsive to your stakeholders, and it's a sensible measure for level 1 work, for the bucket 1 work. So you go through and you do the lean things and you make these kind of improvements. And as we said, we're going to use a histogram. We're going to choose the 80% date. And this is what, okay, well, it turned out we did some more things. I'm going to tell you more about this. I realize now. We looked at 2 teams, and we asked, one of the questions we asked is, and we also looked at at the histograms by level of defect, level 1s, level 2s, level 3. And what we found what was interesting is that the level 3 defects were getting done soonest because they were the easiest, but they weren't the ones the customers wanted, which was the level 1. And so we put in place a policy to fix all that in this example. And finally, this is what improvement looks like. Before, this was the histogram, 80% point was about 105 days. When I got an improvement based on both the policies and the automation things I put in place, I moved in the 80% point to 60 days. And you can just see it because the histogram is squeezed to the left. This is an example of actionable, sensible analytics for the level 1 work. Now, if I try to apply this to the bucket 1 work, the bucket 3 work, I would find I would have it wouldn't make any sense because the things I'm working on there have a lot of uncertainty and I'm not flowing things through. So what would I do in that case? Well, what I'm going to do is I'm going to start working with the fact, I'm going to start out by the admission that my work is already uncertain. And the best, and this is known, like when you do planning poker, this is sort of how planning poker works. When you're asked to size, say, an epic or a story, you work with best case, worst case, likely case. Often they use the Fibonacci numbers, but you don't have to. And then in planning poker, you throw away the highs and lows. What I'm suggesting here is to keep them. And what we're going to do is take the high number. So if when I ask a developer, how long will something take? He says, I don't know. Well, I say, will it take 6 months? He says, no, it won't take 6 months. Will it take 4 months? No, it won't take 4 months. So in the worst case, how long will it take this to get done? Well, no matter what happens, we'll get it done in 2 months. And suppose everything fell together and some of the assumptions you were making worked, how long would it take? And he says, well, I can get it done in a month if everything fell together, but that's pretty unlikely. And what's your best estimate then, since it's between 1 and 3 in your mind, what makes sense? He says, well, let's make it 10 weeks as what I think it's probably going to be. So you take those quantities, best case, worst case, likely case, and you keep them as probability distributions. What you do is you say, you create a distribution which looks like this. The best case, you're saying that there's no probability that it's below the low value. There's no probability that it's above the high value. And it's most likely the peak of this distribution is at the likely value. And it turns out you can add these up. And when you add them up, you get it turns out that you get something that looks pretty much like a bell-shaped curve. So we have tools that can do this, that actually take these distributions of different sizes, of different triangles, and add them up to get a distribution that works. And then as you start working off the stories and epics based on, and people start learning what are going on, you would expect this distribution for the amount of time. You first calculate the amount of time it's going to take as a distribution based on these stories, which means you have to also have an estimate of your velocity the same way. And then you, as a interaction technique, you figure out which one of these things have the widest range. Those are the ones that are the most risky. If a developer says, no matter what, I can get it done in 6 weeks, well, that's the easy ones. Because that means he knows everything about it. But if he says it's going to take between 4 weeks and 20 weeks to get it done, that means there's something he needs to know or she needs to know. And so that means that what you need to do is work on the riskier ones sooner. So when you do that, you get distributions that look like this. So at the beginning of a project, you start adding up these distributions and you start looking at how many of these story points you work off in the first sprint, and you get a distribution of how late you're going to be. Now, at the beginning of the project, usually teams are pretty optimistic, and the red part in this measurement is early, and the blue part in this distribution is late. So after one sprint, it looks like they're pretty much in shape, but there's some probability they're going to ship late. After two sprints, things move to the right, which means they're more likely to ship late. And after three sprints, it turns out that the risky things have caught up with them, and they're in trouble. Now, if you're measuring this way, you have an early look at the fact that you're in trouble already 3 sprints in, and that you're very uncertain to deliver on the time that you need to deliver. So this means you got to take action. And in this case, there's a couple kind of actions you can take. One of the things you can do is do more aggressive content management. This is what I always did in my projects. There may be a feature in this thing which is both risky and not really that valuable. And so with that, you can start moving things back to the right. And then what you see here after 4 sprints is that you're very close to you're still likely to ship late, but not very late. Now you're only 2 weeks or 3 weeks late. You're pretty certain you're going to get in within 3 weeks after 5 sprints. So what this allows you to do is look at the riskier things that are in your project, work off the risk as fast as you can. If it turns out you can't work off the risk, you ask the hard question, what should I do? Should I move the date or should I remove the content? And this way you can manage and steer your program to delivering at a time that the business needs it. And you can look at the value of the features and say, well, how do I prioritize the features so I get the things the business really needs and still make a date that the business really wants? So you see, these are very different. So here's an example of 4 different project patterns using this technique. This is a very common pattern. Everything starts out looking good. It's a green project. It's a green project. Suddenly it turns yellow, but you don't tell your management it's yellow. You say it's green. And then suddenly you're in trouble, and then it's close to release time, and it turns out you're going to be very late. So this is an out-of-control project. I've seen these happen. This is what I sometimes call the green, 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 red project. If you had employed these measures right around here, you would have done something. Okay. This is a project that got a big surprise in Sprint 3. It turns out that none of the things they hoped to get done in Sprint 3 got done. Suddenly they're going to be late, and they took smart action. This is a project that was well managed. It's turned out that they started out by having some probability they'd be early, some probability they would be late. But they worked, that's because things were so uncertain, and they worked off the risk and managed to stay within the target dates, and it actually was able to ship a little early. And this is another example where they had a mid-project surprise, but did the right thing and got themselves right on track. So with these kind of measures where you track the uncertainties, you track the working off of the uncertainties. Now we have tools that will do this, and again, we will explain this in much more detail on how this actually can get done at the Cutter Summit, or you can reach out to me directly. Someone just asked, how do you get, I haven't been really, I apologize, I haven't been reading the questions. There's lots of good questions here, and I'll get to them in a second. But as I said, these are outputs from tools that we've built. And essentially, to answer the last question, how do I get the weeks early and late, is I do this by using the same kinds of techniques to estimate the actual team velocity based on the stories that were completed at each of these sprints. Those are also uncertain. I treat that as an uncertain quantity as well, because if we weren't sure how many story points there were in the story, so we weren't sure really how many story points we completed. But I can divide one distribution by another distribution using Monte Carlo techniques, and then just do a little bit of arithmetic to show how many sprints I have left, how many weeks per sprint, and the like, to see how many weeks late I'll be. And if somebody wants to see this in more detail, I'm happy to explain it. Okay. Another question I had is, do I take into account the worker? How do you include experience and training? Right now, what I'm doing is I'm looking at the average team performance, which just mixes in the team performance of each of the the overall performance of the team. I'm not going down to the individual workers' experience and productivity. Generally, going down to worker productivity is a mistake for a variety of reasons. It's well understood that there's a wide range of capability among workers, and trying to model that, though, gets you into all kinds of issues that generally aren't helpful for these kinds of modeling. There's sort of two problems. One is that in the end, what you really care about is how well the team is performing, and you get that without looking at the worker productivity. The second is the smarter, better, more advanced workers generally get the harder things to work on. And so if you try to measure their productivity in terms of codes, if you try to compare their productivity to the younger, less experienced workers who get the easier things to work on, you don't have fair comparisons. This is like measuring two hospitals. One hospital does routine checkups and simple disease management. The other one is a major teaching hospital that does all the really complicated cases. The second one may actually have a higher mortality rate than the first one, but it's actually a better hospital, this kind of thing. Okay. Again, I'm happy to explain this all in more detail later. So let's move on. We're sort of at the end of the thing. So there's some key principles here. Let me answer this question, then I'll get back to the key principles. The answer is to the last question from Eduardo was yes, I do. And I get the team velocity based on how much I compute that from the actual team performance in the previous sprints. And I don't have to guess at it because I can just get it from the sprints. And again, we'll show this tool at the thing. Oh, the question I got here is, I'm enjoying the questions. Thank you. From Joel is, can I apply the earned value formula, PSP framework to communicate my deadline? The answer is no. And for lots of reasons, which if you'd like, we can have a longer conversation on that. But the PSP earned value stuff makes lots of assumptions which are really not right for development. They assume linear relationships between effort expended and value received. And it's pretty well known that these formulas tend to give you a very false picture. And they also reinforce doing the easier stuff first, not working off the uncertainty. And so what tends to happen if you use those formulas is that you actually manage the programs in the wrong way. You do the easy stuff first, and you leave the riskier stuff to later so they can claim the earned value, and then you're in trouble at the end of the project. Happy to talk about this in much more detail. So anyhow, in achieving goals, let me summarize some very important principles. This is often a quote from Lord Kelvin, who said, to measure is to know. If you cannot measure it, you cannot improve it. Measurements are always, and my point of that is measurements are always part of a feedback loop. If you want to make an improvement, you should if you want improvement, you need to measure where you are, and you need to take measures that are part of achieving that goal. If you just take a bunch of measurements because you have the data and you don't know what you're going to do with them, you're wasting everybody's time. And that's why a lot of developers think measurement's a waste of time, because why are we bothering taking these measurements? We're not going to do anything with them. And they're right to believe that. They're also right to believe they're sometimes oppressive, because all we're doing is measuring things that really don't matter and are a way to pick on the developer. It's sort of like the Dilbert cartoons. But so the converse principle is, if you're not going to do anything with the measurement, don't bother to measure it. Only measure, so you only take measurements you need, and you should know how you're going to respond to them. If you don't take measurements, you don't know what you need in order to make improvements. And then there's the final thing, which I call the Einstein principle, which is the best solution for a measurement should be as simple as possible, but no simpler. And what I mean, so for example, I showed you the example of measuring throughput, and what I showed you was a histogram of the durations of the times it took to get through uh, the value stream for, say, change requests. And I showed you that as a histogram, and we picked as a measure the 80% point rather than the mean. The mean is what people will jump to because it's sort of the simple measure they all think they understand from college. But it turns out it's not a very good and sensitive measure for measuring these kinds of distributions that we're seeing, or the kind of histograms that we're seeing in the real world on for these data flows. I mean, the histograms always look like the way I've in the examples I showed you. So, but taking the 80 percentile is not a very hard measure. It's actually easier, frankly, than the mean, and it's the simplest possible one you could take, or take the 75th percentile, whichever one you want. But it's also, so it's as simple as possible and no simpler. So you should pick the right measure with some sort of thoughtfulness. Um, so this is a summary. There's no one size fits all for choice of measures. Often you'll see books that say the 5 measures every development team needs. I don't think there is such a thing. I think there are a set of measures that really have to be chosen depending on the goals of the team. Sometimes timeliness matters. Sometimes people don't care how long things take, as long as the cost per feature is the measure. And it's interesting fact of queuing theory and modeling and operations that often cost, if you want to minimize costs, that will raise the delay. So you have to choose one or the other, and you have to decide what your goals are. Measures must be part of some feedback, sense, and respond loop, and we've talked about that over and over again. And the choice of measures depend on the mixture of work, and we talked a lot about that today. Whereas if you're doing bug fixes, small changes, point releases, these kind of histogram measures and things that are related tend to be useful for that. If you're doing risk reduction, you sort of look at the probabilities of shipping on time, or probabilities of shipping the kind of features you need. Often they look at the probability of meeting performance goals. People who that's very common in the semiconductor industry. So there's a couple other questions I'll answer, and then I'll take more questions. We have just a few more minutes. The author of the book Flow, again, I'll bring, you should have seen that because there was a mistake in the formatting of the chart, is Donald Reinertsen. I'll spell that for you in the chart window, in the chat window. And his stuff is very important these days. I'm going to speak at another comment. I think they're really, these two things I've shown you are the two key features for the future of analytics and development. One is taking into account the principles Reinertsen talks about, and He has 175 principles in his book. It's not an easy book to read, but it's very good. And a lot of what I do is based on kind of thinking he brings forward. I think it's it's a great read, the second generation product flow. And then the other thing is finally taking into account the uncertainty and taking advantage of the tools we have to deal with uncertain quantities to bring us to the next generation of measures. Let's see, are there any other questions? I see a question in the chat window from Abel Mendiola. These are very similar to the balanced scorecard techniques, and that's true. Are there any differences? I'm not sure. I don't know the balanced scorecard techniques well enough to answer the question in fine detail. I do think, though, that from what I remember reading in the past, they were more subjective than the techniques that I'm going to bring here. So the answer is, yeah, I can see some similarities, but I really can't answer the question with any more precision than that. Alfredo asks, it sounds, I think it's to me like a risk analysis. Yes, it is. There's a good book by Jonathan Munn on risk analysis. And his point is that risk analysis is adopting and managing the uncertainty and quantities that matter to the business. And that's exactly what we're doing. So I sometimes have a saying that I use in the end of my presentations. It's a quote from someone that says, to steal ideas from one person is plagiarism. To steal ideas from many people is research. I do a lot of research. So if these ideas sound familiar, I hope they do, because they are from a lot of really good people. And so with that, I will say thank you. Again, if there's any more questions, I will, please reach me. You have the contact information here. Thank you all very much for attending. Back to you, Jorge.
Okay, Murray, thank you very much for your presentation. Thanks to all the participants for attend this webinar. Gracias a todos por asistir a este webinar. Les recordamos que, pues bueno, el webinar ha sido grabado y se publicará en nuestro canal de YouTube de Software Guru. Los avisos que tenemos, los invitamos a Agile Conference con la edición 15 para este año, las fechas 23, 24 y 25 de septiembre. Les voy a pasar un link donde pueden hacer un preregistro, donde igual pueden hacer válido un 25% de descuento con el código que aparece en la diapositiva. Y pues bueno, Murray va a estar en Agile Conference y John Haynes también. El próximo webinar va a estar a cargo de John Haynes. Entonces, pues bueno, ahí les paso el link para que puedan registrarse para Agile Conference. Esperamos verlos ahí. Tenemos un curso que bueno, va a empezar el 17 de agosto, es el de liderazgo efectivo. Este curso va a estar otorgando 8 PDUs para la certificación en PMP. Si están interesados, pues bueno, ahí también les dejé el link en el chat para que, pues bueno, si están interesados y adquieran el curso, pues bueno, ahí está la liga. Otro curso que estamos ofreciendo es el de Big Data. Bootcamp a cargo de Héctor Cuesta. Este curso va a empezar el 24 de agosto. Ahorita tiene una tarifa temprana bueno, tiene un 10% de descuento. Y pues bueno, va a ser las fechas en vivo 24, 26, 31 y 2 de septiembre. Eh, pues bueno, otro curso que también se va a realizar en el mes de agosto es el de Alphas de Sense. También tiene tarifa temprana, 10% de descuento. Inicia el 25 de agosto. Y este curso va a estar otorgando 12 PDUs para la certificación de PMP. Va a estar a cargo de la doctora Hanna Octava. Así que, pues bueno, si están interesados, ahí también está el link para que puedan, bueno, solicitar información sobre este curso. Y pues bueno, como parte de nuestro plan de desarrollador móvil, también vamos a lanzar en el mes de agosto el curso de desarrollo de apps nativas para iOS. Tiene un 10% de descuento. Este curso es on demand. Ustedes compran el curso y pueden iniciarlo al momento en nuestro sitio, pero pues bueno, va a estar disponible en el mes de agosto. Ya lo pueden adquirir desde ahorita. Otro curso que también vamos a lanzar en este mes es el de desarrollo de UX para aplicaciones móviles. También tiene tarifa temprana. Pues bueno, se va a estar lanzando bueno, a mediados del mes de agosto, a cargo de Mauricio Angulo. Y pues bueno, un curso que tenemos ya listo en el sitio es de desarrollo de apps nativas para Android, con un costo bueno, una inversión de 1,900 pesos. Este curso está a cargo de Adrián Catalán, están en on demand. Ustedes compran el curso y ya pueden acceder a todos los videos del curso en nuestro sitio. En SG Talento, pues bueno, los invitamos a que nos compartan su currículum vitae. Todavía tenemos vacantes disponibles. Ahí les dejé la liga en el chat para que revisen todas las vacantes. Si están buscando trabajo actualmente, pues bueno, ahí tenemos muchas vacantes de la industria de tecnologías de información. Y pues bueno, se acerca SG Virtual en su 9ª edición. Estamos lanzando la convocatoria de ponencias. Si alguno de los participantes se quiere animar a dar una ponencia en SG Virtual, pues bueno, mándenos su propuesta. Ahí también les dejamos el link para que, pues bueno, si quieren aportar con alguna ponencia, pues ahí son recibidas. También, pues bueno, si quieren participar como sede virtual, también nos pueden escribir a eventos@sg.com.mx o si no, pues bueno, la pueden registrar ahí mismo en el link que les dejé en el chat. Pues la sede virtual consiste en un grupo de personas que se organizan para ver juntos pues, SG virtual. Esto pues pasa básicamente en universidades, empresas y espacios de coworking. Um, por ahí Joel pregunta algún tema en particular. Pues bueno, todo lo relacionado con tecnologías de información, Big Data, compiladores, todo lo relacionado a tecnologías de información es bienvenido a SG virtual. Y pues bueno, también los invitamos a la convocatoria de Webinar Launch and Learn de Campus. Si se animan a dar un webinar con nosotros, también pueden hacerlo. Simplemente mándanos su propuesta, ahí está el link para que puedan llenar la información y pues bueno, nosotros lo vamos a evaluar, ¿no? Y los contactaremos. También, pues bueno, igual nos pueden contestar una encuesta de necesidades. Si ustedes necesitan algún curso en particular, les podemos ofrecer un mejor catálogo de cursos de acuerdo a sus necesidades. Simplemente pues llénenos esa rápida encuesta, no les toma ni 5 minutos, entonces será muy bien atendido sus necesidades. Y pues bueno, los invitamos al próximo webinar que estará a cargo de John Haynes, igual introductorio para Agile Conference. El título The Many Levels of Agile Work Visualization. Entonces, pues bueno, también les dejo el link para que se puedan registrar. Again, Murray, thank you very much. Todos los participantes, muchas gracias. Nos vemos en el próximo webinar. Thanks, Murray. See you.
Well, thank you all, and thank you all for the really good questions.